It's like I was saying, combining random variables, taking two different variables and like adding them together. One really important thing with combining random variables, so we're only going to be looking at the means, the medians, standard deviation, and the shape. I think this first point I need to make is if you're going to combine random variables, the means always combine. So hey, what I mean by that is, like if you were adding two random variables together, the mean of the sum would be equal to the mean of random variable x plus random variable y. That's all you have to do. Means you just add together the means of the two different groups. The difference, you have to define, like what you're subtracting. Like if you're trying to find the average distance between how long it takes boys to run a mile and then girls to run a mile or something, the mean of a difference, all you have to do is subtract the means. Always works. So it means it doesn't really matter what the distributions are like or what the variables are. If you want to add the means together, go for it. That's fine. If you want to find the difference, you can subtract the means. Really simple there. This next point I want to make before we start trying to solve some problems with this stuff is the standard deviations. Standard deviations never combine. Should probably stress that point like a little bit more. The standard deviations, if you're trying to add two random variables together, you can't combine their standard deviations. Likewise, if you're trying to find the difference, you can't subtract the standard deviations. It never works, okay? So you will never, ever, ever, ever do something like this. You'll never add the standard deviation from one variable to the standard deviation of another variable. This is like very, very bad. Never, ever, ever do that. Cool, I think that point's pretty clear then. What we can do though, we can add variances. We can add variances if, only if, the variables are independent. Okay? You can only add variances. You can add variances if the variables are independent. What I mean by that is knowing the outcome of one doesn't affect the outcome of the other, or the probability of that other outcome. So for something like, heck, I don't know. If you were trying to combine snowfall in Aztec with the amount of snowfall we're getting in Farmington, those two variables, the amount of snowfall we get like in a year or something in Aztec, and the amount of snowfall we get in Farmington, like an average year, these two variables are probably not independent. Like if it was snowing in Aztec one morning, it's probably going to be snowing in Farmington as well. So knowing that it's snowing in Aztec makes the probability that it's snowing in Farmington go up. That means they are not independent. That means they are not independent, and you can't combine the variances. All right. That situation would not work. So we can come up with an example real quick of something that would work. Two variables that are independent. What are some independent variables? We could Just going back to something I already kind of mentioned, a mile race. Mile race for men. Just to see, like, on average, how much faster do they run the race. You could subtract a mile race time. I should have put time right here too. Time for women. Generally, this is going to be faster. You can subtract and find the average distance, right? So in terms of variances, this is something that's probably gonna throw you off a little bit. So the variance, the symbol for it, is the standard deviation squared. And I'm doing the difference this time. Like, I was trying to subtract these two values. And these are independent. Like, knowing that some guy ran a mile in like 5.5 minutes, it's not going to affect the time that the woman finishes the race. That's why these two variables are independent, and we can add their variances. So the variance for the difference would be equal to the variance for the men plus variance for the women. So again, we're combining these variables and creating something new. We're creating a new distribution. We're creating a distribution for the difference in these times. So even though I am subtracting here, I'm still combining two variables, which means the amount of variation is going to go up. So with these variances, you'll never subtract them. Hopefully that's pretty clear. Essentially, like, the easiest way to remember this is if you start combining more variables, it doesn't matter if you add or subtract them, there's a decent statement you can write. More variables is going to lead to, more variables leads to more variation. So even if we're subtracting, we still have more variables. We're still going to have more variation altogether. Okay, so keep those three things in mind as we try to solve these problems. Means, it doesn't really matter. You can always combine them, either by adding or subtracting. Standard deviations will never combine. We can't do that. But what we can do is add variances, so long as we have a situation like this where the variables are independent. If they're independent, again, you can only add. You're never going to subtract variances. And then you answer that question, why? More variables inevitably leads to more variation. Okay, so hey, let's use these three things to answer some problems where we are combining random variables. Cool, want to? Yeah, fantastic, let's do it. Let me find the page where I had it. I think it was here. Maybe. Yeah, this is it. So how do I get there? I go like this, share. Almost there. I think. Here we go. All right, combining random variables. Just gonna go through a couple of these Khan Academy exercises. Decent problems. Hey, so what do we have here? A certain bowling league has weekly matches where two teams compete against each other. Each team has 4 players whose individual scores are combined to form their team's overall score that week. Based on some data that we already got, they've calculated summary statistics for us. Okay, so here's where the important step is. Let A represent the Alley Cats score on a randomly chosen week. B represent the Bowling Buds score on a randomly chosen week. And then D is going to represent the difference between their scores. Assume that the team scores are independent from each other. Okay, so it's only asking us to find the standard deviation, which is okay. We'll get that in a second. Just to recap some of the things that I talked about, we can always combine means. So it defined the difference as A minus B right here. So the mean for the difference would be equal to the mean for A minus the mean for B. So the mean difference in scores here would be, it would be 630 minus 610. Again, I just got these values from this section right here. So the difference in scores, or the average distance between their scores, is 20, like, I don't know what the unit is, pins or something. There we go. That would be the mean. So the standard deviation, this gets a little bit more difficult. To do the standard deviation, very first thing you need to do, the very first thing you need to do is check for independence. Independence. So it's pretty explicit in this problem, like assume that the team scores are independent from each other. If that statement wasn't there, this would be your answer. Can't be determined. If we didn't know that these variables were independent, then we wouldn't be able to calculate the combined standard deviation. Again, for the mean, it doesn't really matter, but for the standard deviation, it does. All right, so since it kind of passes that first test, since these variables are independent, we still can't add the standard deviations, but what we can do, we can add the variances. So, hey, let's oh, perfect. Yeah. Right on. I'll be here. Totally lost my train of thought. Oh yeah, hey, so we already determined that these variables were independent, which means we can add their variances. So, remember, it's subtracting, but it doesn't matter. I'm combining variables. More variables means more variation. So I'm still going to add the variances. So the variance for D, the difference, is going to be equal to the variance for random variable A plus the variance for random variable B. Okay, so now it becomes pretty important. It's kind of like a review. We need to know how these standard deviations relate to variances. And it's like, that's right here. If you square the standard deviation, you get that variable's variance. So I'll put equals here, and I'll start plugging in the standard deviations. Like it literally gives it to us right here. Standard deviation for A is 80. So this would be equal to 80, but squared, plus the standard deviation for B, which is 60. And then to get to the variance, of course, we square it. Okay, 80 squared, would that be like 6,400 maybe? I think. And then plus 60 squared, which would be, I think, 3,600. Okay, so I'll add these two things together. The total amount of variance we have now is 10,000. Right. Again, that's the variance. So to get the square root for the difference, we will find the square root of this variance, of the total amount of variance. I've got that written down correctly. So what would that be? I think just 100 maybe? I don't know. I should probably like actually get a calculator out and do this. Square root of, what am I doing? 10,000 is 100. Which makes sense, right? Because if we square it, 4 zeros. Okay, all done with this problem then. The standard deviation for the difference would be 100 pins. The mean would be 20 pins, but the average distance to the mean would be 100 bins. Okay, fantastic. Open it up for questions real quick. Like, is there anything here that it talks about that's maybe not so clear, not making sense? Or just, yeah, let's practice some more and we can do questions later. All right, so let's go to the next question, see what we got. Okay, so again, we're finding the standard deviation. Jerome is a dietitian who tracks his daily caloric intake from different sources of nutrients. Here are summary statistics for his daily values. So we've got his calorie source, mind your macros, fat, protein, carbs. We've got the mean that he eats of each one of these and the standard deviation. T is the variable that's going to represent the total calories from fat, protein, carbohydrates that he consumes on a randomly chosen day. Find the standard deviation. So if you're ever asked to find the standard deviation, you need to establish something first. Do you know what that something is? What do we need to establish first? You know? You don't know? You don't know, now you know? Independence, thank you. Hey, are these variables independent or not? I think the answer to that question would be these three variables, fat, protein, carbohydrates, they are probably not independent. Like, if we know the dude like was eating some steak that was really high in protein, it was like a fatty cut, it's probably gonna be high in fat. If we know he had a lot of protein, he probably had a lot of fat that day as well. Okay, so the answer to this question is actually gonna be super easy. Find the standard deviation of T. Too bad, we can't. Knowing the outcome of one could affect the outcome of the other. So we're actually not gonna be able to calculate the standard deviation. Now, if it asked for the mean, we could have done this. We could just add up the mean calories for each variable. The mean doesn't matter. The mean doesn't rely on independence. Just the standard deviation does. Okay, fantastic. We'll try another one. This time, Andy and Jim are going to compete in some 100-meter dash against each other. A is the time it takes for Andy to complete the race, while J is the time it takes Jim to complete the race. Based on some previous results, we know that the mean for A is 11.5, standard deviation 1. The mean time for Jim is 10.5 seconds, and his standard deviation 0.5 seconds. Okay, assume that their times are independent. That would be important for standard deviation. So hey, D is the difference between their times. And it tells us, this is an important statement because it tells you what to subtract. Like, we need to know which variable gets subtracted, which variable is taken away from the other. So the statement does matter. Like, we wouldn't want to do the mean for J minus the mean for A. So anyhow, we're only doing the mean this time, which means I can do the mean difference, or I can calculate the mean difference as the mean for A minus the mean for J. Gives it to us in the problems up here. Mean for A is 11.5. Subtract the mean for J, which is 10.5. So our mean difference is, there's like 1 second. Okay? Okay. 1 second. Fantastic. I believe if I would have put -1 there, like I switched the subtraction around, it probably would have marked me incorrect. Okay, so we did 3 of these, like pretty quickly. Do you want to go through any more? Like a few more practice problems? Any questions at this point? Anything? Got nothing? That's the book.